Alright, in this video we're going to do a quick review on how to solve equations. We're going to kind of skip over one and two step equations since we kind of do that within these types of equations. So we're just really going to focus on the distributive property and combining like terms. So if you remember, the very first thing you always want to check for is if there's a distributive property, and that's when we have a number on the outside and an expression on the inside of the parentheses. So in this case, I am taking the 4 and distributing it to 2x and 3. So 4 times 2x is 8x. 4 times 3 would be plus 12. And I have equals 20. Now this is our two-step equation. So remember we use inverse operations to solve this. Because I have plus 12, I'm going to subtract 12 from both sides. This cancels out and I'm left with 8x equals 8. Here's our one-step equation where all we have to do is divide since this is multiplication. I am dividing by 8. These cancel out. 8 divided by 8 is 1. And then don't forget, you can always check this answer. So I could take some time to put this 1 in right here and see if it winds up equaling 20 when I do all my multiplication and adding. For the second one, we have combining like terms here. So I know a lot of people like to sort of maybe underline things that can go together, maybe put them in boxes. However you want to do that is fine. So you'll see in this case we can put together 5x and it's plus 2x, so that would be 7x. I have a positive 3 and this is actually like a negative 4. So I can either do 3 plus negative 4 or I could do 3 minus 4. Either way, we get the same thing, which would be negative 1. So I'm going to write that as minus 1, and then it equals 13. Here's my two-step equation where I'm going to add 1 to get rid of this. 7x equals 14. I'm going to divide by 7, and then x equals 2. And again, I can take that answer and plug it in everywhere I would see an x. And if I do all of this, I will get 13. Now that we did our multi-step equations, we're going to take it one step further and do our equations that have variables on both sides. So we still have the same steps as far as we always want to check for distributive property first and then combine like terms. But remember that it's only things that are on the same side of the equal sign. So in this example here, I can distribute on this side. I'm not going to worry about this side quite yet. So I'm taking my 3 to the 2x and to the 4. 3 times 2x is 6x, plus 3 times 4, which is 12. On the other side, I have 4x minus 2x, which is 2x, and then my minus 4 stays there. So remember, you kind of want to get this to a simplified expression on each side before we actually start solving. Now at this point, it'll be easiest if we move around the variables to get them all on the same side. So I could either subtract 6x or subtract 2x, but remember we talked about how it's usually easier to move the smaller coefficient because then we can kind of avoid negatives. So I'm going to subtract 2x. This goes away. 6x minus 2x is 4x. And my plus 12 stays there. And now I have a negative 4. Don't lose those negatives in here when they act as minus signs. Now I just have a simple two-step equation, right? So I can subtract 12x. This cancels out. I'm left with 4x. Negative 4 minus 12 is negative 16. And now all I have to do is divide by 4 on both sides. And I'm left with x equals negative 4. And again, I could have subtracted 6x from both sides instead, and I still would have gotten the same answer. So that's up to you. If you also remember, when we have variables on both sides, we could have some special cases, like where we don't actually get an answer, like x equals a number. So in this case, again, I'm going to check for distributive property, but there is none. I do have combining like terms, though, on the other side. So I have 3x minus 10. 2x plus x is 3x minus 10. So at this point, you might notice that we have the exact same thing on both sides. But just to kind of prove what's going to happen here, I could subtract 3x, and then I am left with negative 10 equals negative 10. Because this is a true statement, this is infinite solutions. So remember, we can't just leave it like this. We have to take that extra step and write infinite solutions. There's also that symbol that some of you like to do that kind of looks like that R. And then we also have this case as well. So again, we want to distribute first if we can. So I have 3 times 3x and 3 times 1. So I have 9x plus 3 equals 9x minus 6. Now notice that we don't have the exact same thing on both sides, but we do have this 9x on both sides. So if I subtract 9x on both sides, I am now left with positive 3 equals negative 6. Obviously that's not true, right? So this is where we have no solution. And again, you must write that out or use the symbol with the 0 with the slash through it. So this covers all the different types of equations that we have done this year. So hopefully this will help you as you go on to do the quizzes. There's also a PDF posted that has kind of like some steps to go through. So again, if you don't want to come back and watch this video, you have the option to look at that as well.